So you know that scene in Interstellar?
Yeah.
The one where the physicist grabs a piece of paper, draws two dots?
Oh, the folding the paper trick? Yeah. Punches a pen through it?
Exactly. The classic wormhole is a shortcut explainer. It's, the cosmic subway system.
It's a great visual. It's basically how every sci-fi movie gets you to another galaxy in under 2 hours.
Well, deep dive we're looking at today, based on a new study from the University of Portsmouth, it basically takes that folded paper and just throws it in the shredder.
It really does. A few researchers, Gastanyaga, Kumar, and Marto, they're proposing this thing called direct sum quantum theory. And it's not just saying traversable wormholes are improbable.
It's saying what? That they don't work like that at all?
It's saying the math doesn't create a tunnel, it creates a mirror.
A mirror. So, hang on. If I jump into a wormhole, I don't come out in the Andromeda Galaxy.
No, not in this model. The throat of the wormhole connects two sheets of space-time, but they aren't two different places.
Then what are they?
One sheet is our world, where time, flows forward. The other is a mirror sector, where time flows backward.
A backward time universe. Okay, that sounds less like physics and more like a really confusing movie plot. Why? Why would the universe need that?
Well, it comes down to cleaning up the mess that black holes make. There's this massive problem in physics called the information paradox.
Right. If a black hole evaporates, all the information about what fell in can't just vanish.
Exactly. Information is supposed to be immoral. This mirror theory solves it. The information isn't destroyed, it's just preserved in the quantum connection between our universe and the backward one.
So it's a closed loop. Nothing gets lost, it just gets reflected.
Precisely. It even gets rid of so-called ghosts, these unstable, negative energy states that usually break these kinds of models. Here, they're just physical states moving backward in time.
Okay, so it fixes some tricky math, but it kind of kills the dream of interstellar travel.
On the micro level, yes. But this is where the theory goes from disappointing for sci-fi fans to something much bigger.
I've seen the headline in our source material, but walk me through it. Because honestly, it sounds insane.
It's the black hole universe model. Basically, if you take the density of our universe and calculate its Schwarzschild radius,
Which is the size of the event horizon for a given mass, right?
right, you get a radius of about 5.1 gigaparsecs.
And that number is significant
Because that's almost exactly the size of our observable universe. The math implies we aren't looking at black holes from the outside. We are living inside one.
Okay, but if we're inside a black hole, shouldn't we be crushed into a singularity? I mean, shouldn't it be lights out?
That's what classical physics would tell you, yes. But this model replaces the singularity with a big bounce. As everything collapses, it gets squeezed tighter and tighter until the quantum exclusion principle kicks in.
The rule that says two particles can't be in the same place at the same time.
Exactly. It creates this immense pushback, a kind of degeneracy pressure. The collapse hits a quantum wall and literally bounces back out. And that bounce, that's what we call the Big Bang.
So we're not in a one-way trip to oblivion. We're in the expanding phase of a breathing black hole.
You could put it that way, yeah.
This actually seems to solve another problem, doesn't it? We usually explain the universe's expansion with dark energy, this mysterious force pushing everything apart.
It replaces it entirely. You don't need some mysterious vacuum energy. In this model, the bounce itself creates negative pressure. The equation is just P equals oot. That pressure is the expansion. It's just geometry.
That's incredibly elegant, but I'm always a little skeptical when a theory ties everything up a bit too neatly. Is there any hard evidence for this?
There is, and it's data that has been bothering astronomers for years, actually. It's in the cosmic microwave background.
The baby picture of the cosmos.
Exactly. NASA and ESC satellites have found these anomalies, specifically something called parity asymmetry. The temperature fluctuations in the universe are, well, they're lopsided.
Lopsided? How so?
The standard model just says, oh, that's a random fluke, just bad luck in the data. But the black hole universe model predicts that lopsidedness. It's a natural result of the connection to the mirror sector.
So it explains something we've already seen.
And when they ran a Bayesian analysis, which is just a way of calculating which theory the evidence supports, the data favored this new model over the standard one by a factor of over 650.
650. Wow. Okay, that is not a rounding error.
No, that is statistically decisive. It suggests the lopsided universe isn't a fluke. It's the smoking gun.
It really just shifts the entire narrative. We aren't these lonely travelers in some infinite void. We're inside a unitary recycling system. It feels Strangely organic.
It's a cyclic view of the
Ah.
cosmos, absolutely. No cold death, just an eternal breath in and out.
Which leaves you with a really heavy thought to chew on. If time is just a coordinate with a perfect mirror reflection, then is our feeling of now, this sensation of moving forward, just a trick of perspective?
It could be. Just an illusion caused by being stuck on one side of the glass.